This is the 2016 Math Kangaroo, levels 9-10, problem number 26. Two heights of a triangle have lengths 10 centimeters and 11 centimeters. Which of the following cannot be the length of the third height? A, 5 centimeters, B, 6 centimeters, C, 7 centimeters, D, 10 centimeters, or E, 100 centimeters. This is the problem as it originally appeared on the test. And here is where we'll be doing the solution. To start, I have drawn a triangle and labeled the vertices A, B, and C, and I've labeled the sides. So the side opposite vertex A is lowercase a, opposite vertex B is lowercase b, and same with C. Now, we know that the problem tells us that we have two heights that are lengths 10 and 11. But in order to approach this problem, I'm going to forget about the fact that we know what two of the heights are. We're just going to develop a relationship between the heights of a triangle and the length of the sides, and then we'll go back and plug in 10 and 11. So what I've done is I've drawn a height from each vertex. So the one going from A is length X, the height from B is Y, and the height going from vertex C is Z. So what do we know about the lengths of the sides of a triangle? Well, we know that for, let's say, side C, we know that side C must be greater than the absolute value of the difference of lengths of the two other sides, so the absolute value of A minus B. And we know that this side C must also be less than the sum of the other two sides. This is an inequality that's true for all triangles, and we will use it throughout this problem. So next, we want to again, relate the sides of a triangle and their heights. So we know that all of these have in common is that they form the area of a triangle. We can write the area, again, it's base times height over 2. So it's equal to ax over 2, by over 2, cz over 2, and again, they're all equal to the area of the triangle, which I have written as S in this case. Now we want to solve for the sides A, B, and C because again, we want to be using this inequality over here. And the only way we can relate the sides and the heights is by substituting one for the other. So we know that A is equal to 2s over x if we solve using this equation. B is equal to 2s over y, and C is equal to 2s over z. So now again, like I said, we're going to use this, and we're going to replace A, B, and C with these values. And this is what we're going to get. Well, as you can see, we have 2s as the numerator in all of these fractions. So we can simplify that and get 1 for the numerator for all of them, as you can see in this step. Next, we can combine the two fractions in order for them to be easier to work with. Over here, simplifying this, we get y minus x over xy, and then this becomes y plus x over xy. This will make it a little easier for us to make sure we don't make any mistakes in the next few steps. So next we're going to use a rule that states that when you take the reciprocals of positive numbers, it reverses the direction of the inequalities. So for example, let's say I have p is less than m, which is less than n. These are just 3 random variables. Then we know that 1 over n is less than 1 over m, which is less than 1 over p. This is a rule. And as you can see, basically what happens is that when we take the reciprocal, the signs will switch, because you see n is over here, now n is less than 1 over m, but over here n was greater than m. So all the signs, again, will switch when we take the reciprocal. So we want to make z no longer be 1 over z. We want to take the reciprocal of this entire thing. And when we do that, again, the signs change. So the reciprocal of this fraction will end up on this side. It'll end up being less than z. Again, because of the rule we just talked about. And the reciprocal of this will end up being greater than z. So again, now we've taken the reciprocal and switched the signs. Now is when we can use the two values that we have. We can say that x and y are 10 and 11 centimeters, because again, we know that two of the heights are that. And we can come up with a very nice inequality. We know that xy, which is 110, over y plus x, which is 21, must be less than z, and z must also be less than xy, which is again 110, over y minus x, which is 1. And the absolute value of that will be 110. So let's look at the lower bound. We know that z must be greater than 110 over 21, which we can see is greater than 5. It's about 5.24, which means that z must be greater than 5 and must be smaller than 110. So if we look at our answer choices, we see the only number that does not fit in this inequality is answer choice A, because we know that z must be greater than 5. Thank you so much for watching, and please subscribe if you'd like to see more videos.